Dr. DeMont here, and welcome to Security for Hackers and Developers, Exploit Development. In this course, we're going to cover auditing, debugging, and vulnerabilities. First, we're going to talk about why would you want to exploit a program. There's some obvious and maybe some non-obvious reasons. Then we're going to look at auditing a binary. We're going to audit some code, and we're going to learn to start debugging that. So what could be hacked? Well, you might be asking yourself, what couldn't be hacked? And that's about right. Everything's getting hacked these days. That's why there's such a need for security professionals. Anything from desktops, laptops, servers, mainframes, mini computers, mobile phones, tablets, network security things like your home router. And that can be worse than it sounds because a lot of people work from home occasionally too. So if your home router gets hacked, perhaps that gives attackers a VPN access into a sensitive corporate network. So a lot of these are even worse than they may sound. Industrial control systems, power plants, buildings, factories, machines, building controllers that control the HVAC in your building. All of those things are oftentimes very hackable and not quite as well protected as they should be these days. Cameras, IoTs, we find those all the time when we're doing security assessments and pen testings. That's some of what we do at VDA Labs. Gosh, I could tell you stories all day long about the crazy things we find. Well, and in the past, people would say, well, so what? What's the big deal? What's the big problem if something gets hacked? Privilege is when an attacker goes from less privilege, like outside a network, and they cross a privilege boundary, and all of a sudden they're inside a process or inside a network or inside something that they shouldn't be into. And that gives them all kinds of abilities to perform unauthorized actions. Anything from ransomware, theft, fraud, blackmail, changing a database, changing your grades, who knows what. There's also other reasons, and these are somewhat more legitimate. Some people actually hunt for bugs for a living. There's companies that pay bug bounties, and if you find a new exploit against something reasonably well known, like Microsoft Office or whatever it may be, you can sell those in many cases and make some real money doing that. And there's different markets, of course, and I encourage you not to sell on the black market, but there's sort of this white and gray market. The white would be bug bounty markets, and the gray market would be more like selling to defense contractors and stuff, and that's a perfectly legitimate market. Some people have mixed feelings on it. They kind of wonder what our various governments going to do with that, but that's a whole different discussion. And of course, what will hackers do with a bug that have maybe some agenda, for example, defacing a web page, DDoSing some site to take it down, some political reason, fake news, who knows what. Most of it, honestly, in this day and age is just monetary based, right? So they want to hack a company so that they can steal all the credit cards and sell them on the market and make some money and things like that. There's also much more nefarious things that could be done, right? Like the Internet of Things really gives us a new way to hack, right? Before it was all about taking. I could hack a company and take their credit cards, take their information, take their social security numbers, whatever it may be. With IoT, you can reach out and touch something, right? You could turn a building controller on and turn up the boiler and burn down a building, and that's really scary. So there's a lot of reasons why we want to learn about exploit development so we can better protect our software. Now, there's a lot of activities closely related to exploit development, but they're not quite exploit development, and we'll just kind of point out some of those now. So, for example, vulnerability scanning would be like using Nessus or some other vulnerability scanning tool to find potentially vulnerable servers in a network, and that's something that a blue team might do or a pen test might do, but it's not really something that you would do during the actual exploit development process. Same thing with software testing, and that's very even closer related to what we're talking about. That would be finding bugs, making sure your software works, making sure it doesn't crash, but typically, of course, with the sense of, hey, we better just fix these. And this is the most closely related to exploit development because sometimes it's necessary for developers to understand if you've got a ton of bugs, you've got 1,000 bugs to fix, which are the top 10, which are the most likely to be exploited, the most severe if they're exploited. And so that's one of the main reasons why you would really want to learn this exploit development stuff so that you can better triage your bugs. Sometimes that's tricky though because sometimes software testers might lack hacking expertise or really a strong security background. So that's a place where you can have a security champion in a company that has this background that can work with testers and developers to help explain that and understand that. And that's hopefully after this class, that'll be you. Right, you'll have the ability to better understand these. And of course, there's penetration testing, which we've been talking about, and that might be using exploits in tools like Metasploit or Canvas or other, either open source or commercial pen testing tools. And that's more using an exploit to gain access to the system, and that's really not what we're talking about here either. We're really talking about finding new O-day or zero-day exploits and learning how to find, hey, this thing crashes when I do this. Is it possible for me to translate that into an actual exploit? Software exploitation is not the only means of exploiting a system or a person or a company. There's all kinds of other things, right? There's supply chain. That would be like embedding a secret backdoor on a device or intercepting somebody's mail and planting a backdoor or something like that. And those are obviously very difficult to defend against. That's not what we're talking about here, though. Same thing with other things like social engineering, calling up somebody and tricking them and asking them for their password or whatever it may be through email and phishing. So it's often a combination of a technical attack, could even be a physical attack, but there are courses on Pluralsight where you can get training to defend against social engineering. So what we're really talking about here is unknown software vulnerabilities, sometimes in the sort of government world called CNE, Computer Network Exploitation, or CNO, Computer Network Operations, and the defense would be CND, Computer Network Defense. Those are all just, there's lots of acronyms when you work in government space. But either way, writing new exploits is what we're talking about here. And of course, it's crazy how specialized our world is now today. For example, security is already a niche in IT. And even within security, you have many more niches like reverse engineering and forensics and all of these different things, exploit development, the one we're talking about now. And even within exploit development, you have a variety of specialties. Things like, some companies may focus on web exploits, or another company may focus on only compiled, C and C++ exploits, things like that. So it's really interesting to see how specialized companies are. But in this course, we're talking mostly about either closed source, mostly, or open source as well, where we can fuzz or reverse or audit the code in some way to find a bug. We're typically looking at C and C++ in this course. And then we want to figure out what can we do to exploit that bug so that we can help understand how it is possible for many of these bugs, some of which don't even look like they would necessarily be exploitable on the surface, could actually be exploited. That'll help us triage again. So assuming we've found a bug, it was either reported to us as a company, or we found it in testing, or we found it in fuzzing, or code auditing, whatever, what do we do to actually try to make that into an exploit? So this process of going from a bug to a POC, a proof of concept, to an actual working software exploit, that's what this course is all about. And the knowledge that we need to do that is pretty extensive, right? We need knowledge of operating systems that we're going to target that this binary would run on. Windows and Linux, for example, are some of the most common, Mac OS X. We need knowledge of the architecture. So x86 is still very common, 64-bit in many cases now, but of course there's so many more now, PowerPC, MIPS, ARM, you name it out there. And we also need knowledge of the software development process. Was this code written in C and C++ or C#, or what compiler was used, what compiler mitigations might slow this exploit down, what operating system mitigations might slow the exploit down, so many different things. And then we need, of course, reverse engineering tools and techniques, and that was covered in the prior course. And then in this course, what it's all about are the exploit development tools and techniques. So what are those exploit development tools and techniques? It's a creative process, right? I mean, all bugs are different nowadays, and there's so many different ways to go about trying to overcome various obstacles as you're doing this, but there are some common patterns of bugs and common patterns of things that we can apply. In particular, one of the most universal skill sets you'll need is to be able to be proficient in a debugger, being able to use WinDebug or IDA or Munity on Windows, or GDB and the like on Unix. It's really important. Also, network programming and shell coding, there's a lot of other niche skill sets that'll be really important to be able to actually land the exploit. We'll talk more about the attacker payload called the shellcode in a coming module.